We now considering another problem which contains polynomial both in numerator and denominator. So we have x plus 1 in the denominator. We cannot express numerator in terms of x plus 1. So we can do one thing. Let us substitute x plus 1 as t and we try to simplify the numerator. Substitution here is x plus 1 is equal to t. From this we will get x is equal to t minus 1. If we differentiate this with respect to x, we will get dx is equal to dt because derivative of 1 is 0. Now the given problem reduces to x to the power of 5 becomes t minus 1 whole power 5. Whole divided by x plus 1 becomes t. So now we will integrate this with respect to t. Before that, we need to expand t minus 1 whole to the power of 5. We know that from the binomial expansion, x minus a whole power n is equal to x power n minus nc1 x power n minus 1 into a plus nc2 x power n minus 2 into a square and so on ncn x power a power n. So here in place of x we have t and in place of a we have 1 whereas n is equal to 5. So we'll use this expansion and we'll write the expansion of t minus 1 whole power 5. We will get t power 5 minus 5c1 t power 4 plus 5c2 t cube minus 5c3 t square plus 5c4 t minus 5c5 1. We can stop here. Now what is 5c1, what is 5c2 and 5c3? We know that NCR is equal to n factorial by n minus r factorial into r factorial. And also we know one of the beautiful property of combination NCR can be written as NC n minus r. So from these two properties we'll get the standard values of 5c1, 5c2 and so on. 5c1 is equal to 5 which is same as 5c4 because using this property 5c1 can be written as 5c 5 minus 1 which is again you will get 5 only. And again 5c2 is same as 5c3. So you simply use this formula and simplify. We will get 10. And 5c5 is 1. So that the given problem reduces to integral of. So here t to the power of 5. 5c1 is 5 minus 5 t power 4. 5c2 is 10. 10 t cube minus 5c3 minus 5c3 is 10 times t square plus 5c4 is 5t minus 1 whole divided by t. We'll integrate the whole thing with respect to t. So here we'll just split this. T to the power of 5 by t is t power 4 minus 5 t power 4 by t is t cube plus 10 t cube by t is t square minus 10 t square by t is 10t plus 5 minus 1 by t. So this is equal to integration of t power 4 is t power 5 by 5 minus 5 times integration of t cube is t power 4 by 4 plus 10 times integration of t square is t cube by 3 minus 10 times integration of t is t square by 2 plus integration of constant is 5 into t minus integration of 1 by t is log t followed by the constant c. Now we will replace t by x plus 1. So here where t is equal to x plus 1. This gives the required solution. We are considering a problem which contains fractions in the powers. Whenever we get such problems, so the only option is you take LCM of both the terms of the denominators. So here for half and 1 by 3, here I consider 2 and 3. For 2 and 3, LCM is 6. So we will substitute x as t to the power of 6. If you differentiate this with respect to x, we will get dx is equal to 6t to the power of 5 into dt. From here, we can write t as x to the power of 1 by 6. And if we substitute this in the given problem, we will get 1 over this x to the power of half becomes, we are replacing x with t to the power of 6. So this becomes t power 6 whole raised to the power of half. This is same as t cube. And x to the power of 1 by 3 becomes t power 6 whole raised to the power of 1 by 3. So this is same as t square. If we do all this substitution, the given problem becomes t cube plus t square and dx is 6t to the power of 5 into dt. So 6 is constant, we'll keep it outside. So we will get, see here, in the denominator we can take t square common and we can cancel the same with the numerator. So we will remain with t cube, whereas the denominator becomes t plus 1 into dt. So here you can solve this problem by two methods. One is you substitute the denominator t plus 1 as some other variable u and integrate, or else we have t plus 1 in the denominator. We try to make numerator in terms of product of t plus 1. So for that you add and subtract 1 to the numerator. We will get we can split this integral as t cube plus 1 by t plus 1 minus 1 by t plus 1. And this t cube plus 1, we will use the formula a cube plus b cube. We know that a cube plus b cube can be written as a plus b into a square minus ab plus b square. So this becomes t plus 1 into t square minus t plus 1 whole divided by t plus 1 minus 6 times integral of 1 over t plus 1. So here in the first term t plus 1 gets cancelled. We will get 6 times integration of t square minus t plus 1 minus integration of 1 by t plus 1 is log of t plus 1. So this is 6 times log of t plus 1 followed by the constant c. So we need to integrate first term now. So this is 6 times integration of t square is t cube by 3 minus integration of t is t square by 2 and integration of 1 is t minus the 6 log of t plus 1 will write as it is, followed by the constant c. So this is the required solution for the given problem. Whenever integrals of the form tan power mx secant power 2nx dx are cot to the power of mx into cosecant square power n x into dx is given. Here m and n are any integers. So substitution here is, in the first integral we will put tan x is equal to t, whereas in the second integral we will put cot x is equal to t. So now let us consider a problem of similar kind. Integral of tan power nx into secant square x dx. So here we will do substitution as tan x is equal to t. We know that derivative of tan x is secant square x into dx becomes dt. So that the given problem becomes integral of tan x is t. So tan to the power of n becomes t to the power of n. And secant square x into dx becomes dt. So now integration of t power n is t power n plus 1 by n plus 1 followed by the constant c. We know that here t is tan x. So we'll replace t by tan x. We'll get tan x whole to the power of n plus 1 by n plus 1 followed by the constant c. So this is the required solution for the given problem. We now integrate secant to the power of 4x with respect to x. We know that integration of secant square x is tan x, but integration of secant to the power of 4x, which we have not obtained standard formula, but we can write the same as secant square x into secant square x, and 1 secant square x we will express it in terms of tan x, so that the problem can be solved by the method of substitution, which reduces to one of these forms. So let us write secant to the power of 4x as secant square x into secant square x dx. We know that from the properties of trigonometric identities, secant square x can be written as 1 plus tan square x. And this secant square x will write as it is. So that this problem reduces to 1 into secant square x dx plus tan square x secant square x dx. The first integrand, when we integrate secant square x, we will get directly tan x plus, whereas the second one, if you put tan x is equal to t, we will get secant square x into dx as dt, so that this reduces to t square into dt. Tan x is t, so tan square x is t square, and secant square x dx becomes dt. This is equal to tan x plus integration of t square is t cube by 3 followed by the constant c. So this gives us tan x plus, here t is tan x, so we will get t cube as tan x the whole cube, whole divided by 3 followed by the constant c. This is the required solution for integral of secant power 4x. Let us consider one more problem of the type cot to the power of mx into cosecant to the power of 2nx dx. So here we know that the derivative of cot x is cosecant square x, but we have here cosecant to the power of 4x. So what to do with one more cosecant square x? That is a question mark. So what we can do is, cosecant square can be expressed in terms of cot. So let us try that. We will rewrite the given problem as cot square x, cosecant square x, cosecant square x into dx. So 1 cosecant square x can be expressed in terms of cot x here. So we will get cot square x into 1 plus cot square x into cosecant square x. So now we can go for substitution method. Just put cot x as t. Derivative of cot x is minus cosecant square x into dx becomes dt. So the given problem reduces to cot square x is t square into 1 plus t square, and cosecant square x into dx becomes minus dt. So this is going to be minus of t square plus t to the power of 4 into dt. So just integrate this. We'll get integration of t square is t cube by 3 plus integration of t power 4 is t to the power of 5 by 5. Followed by the constant c. Now we will replace t by cot x. We will get cot cube x by 3 plus cot to the power of 5x by 5 followed by the constant c. So this is the required solution. Even if a question like tan square x into secant to the power of 4x is given, same procedure we will follow. We will write secant to the power of 4 as secant square into secant square, and 1 secant square you should express it in terms of tan and follow the same procedure. We can integrate the same way. We now consider integrals of the form tan to the power of nx or cot to the power of nx. Whenever these type of integrals are given, we try to express tan to the power of nx in the form of tan to the power of n minus 2x into tan square x, so that this tan square x can be expressed in terms of secant square. We know that tan square x can be written as secant square x minus 1 because the derivative of tan is secant. I can put this tan x as t so that I'll get secant square x into dx is equal to dt. So let us consider a similar problem here. We're having tan to the power of 4x into dx. Here we'll write tan to the power of 4x as tan square x into tan square x so that 1 tan square x can be written as secant square x minus 1. So this can be written as tan square x secant square x dx minus tan square x dx. So the first integral can be solved by the method of substitution. If you put tan x is equal to t, we'll get secant square x into dx as dt, so that it reduces to the form tan square becomes t square and secant square x into dx becomes dt minus integral of, here we know that tan square we cannot integrate directly. So we will convert tan square in terms of secant square again. So we'll get secant square x minus 1 into dx. So this is first integral. Integration of t square is t cube by 3. I'll replace that t as tan x. So I'll get tan x the whole cube by 3 minus integration of secant square x is tan x, minus into minus is plus, integration of 1 is x followed by the constant c.